The first thing to discuss is that now is a good time that you extend your imagination for visualizing motion in terms of acceleration, velocity and displacement to include the applied forces also. So by this I mean that, for example, now you are in a position that if you are given with the displacement versus time relationship, you can make a picture in your mind about how that motion would look like, right? You can convert it into velocity versus time and acceleration versus time by successive differentiation. Similarly, you also now know that if you are given with acceleration versus time relationship or acceleration in any form, you can convert it into velocity and displacement by successive integrations, right? So for example, if I give you a case that the acceleration of a particle was equal to plus 10 meter per second square for, let's say, first 3 seconds. So from 0 to 3 seconds on this acceleration versus time graph, it had a constant value of plus 10. Then it remained 0 for around, let's say, 4 more seconds, so maybe up to 7 seconds it remains 0, and then from 7 onwards, let's say its value become some negative number and then state that negative number up to any time t. So let's say if it has a value of, let's say, minus 5 meter per second square, and then it state the same number, constant number, up to any time t. So now you know that if this information is given, you have to divide this motion into 3 parts. A part with a constant acceleration of 10 meter per second square, and that part will be from 0 to 3 seconds. From 3 to 7, it is acceleration equal to 0. And then from second onwards, acceleration have again a different value, it's minus 5 meter per second square. You can perform successive integrations for all these 3 cases to come up with velocity versus time relationship, which might look something like this. For example, on the same time scale, obviously when the acceleration is positive, which means velocity is increasing, right? So let's say that it starts from 0 value and then it increases up to a certain number, right, in first 3 seconds. From 3 to 7 seconds, the line should become flat from 3 to 7 seconds, right? And then from 7 seconds onwards, the acceleration become negative, which means now the velocity should decrease, right? So it will decrease now, and at certain time it will become exactly 0 and then keep on going in minus direction up to any time t. As long as you have this negative acceleration, you will have the velocity keep on reducing. Similarly, if you plot the displacement versus time, so this first graph was acceleration versus time, then we have v versus t, and we can also have s versus t. So we know that for first 3 seconds velocity is increasing, so displacement would also be increasing, right? So at first 3 seconds it will have some value, for example like this, first 3 seconds. From 3 to 7 seconds the velocity remain constant, but displacement will still keep on increasing, right? Velocity is a constant value and the displacement will still keep on increasing, but not at the same rate as it was increasing in the first 3 seconds, right? So when velocity was also increasing. So maybe after some time at 7th second it will go to maybe somewhere here, right? So if this 3 second time is this, so exactly at the same time you will have this number, and then at 7th second you may have this number, right? From 7 seconds onwards the velocity start decreasing, right? but acceleration should still continue to increase in the same direction for some time, and at the time instant when exactly velocity change its direction, the displacement will be at its peak, right. So the displacement should look something like this after 7th second, that it should be at maximum value at the time when the velocity was 0, and then after that when velocity became negative, which means now displacement will start reducing from that peak number, and it will continue reducing like that, right. So now you can make a picture of this motion in your mind with all of these graphs, right. So all I want now was to just extend your imagination to think in terms of forces also, although we will discuss that thing in more detail when we reach to kinetics part. But now let us extend your imagination and think what forces you would require to produce this motion, right. If I give this particle in your hand, what forces would you apply to that particle to reproduce this motion for that particle, right. So please extend your imagination and think of like physical scenarios where you are required to produce a particular given motion, and you have to design a force application mechanism or think of the forces which will produce that motion. Like if you are given with that particle in your hand and ask you to produce this motion, this acceleration, this velocity and corresponding displacement, what forces you would apply on that particle to produce this, right. So this is an additional thought experiment which I would like all of you to try from now onwards. You will always be having problems in which acceleration is given directly without reference to forces in kinematics, but now you are in a position to start visualizing the forces also, like what forces would be required to describe this motion, right. Now this skill, if you can develop in this course to visualize force required to produce a motion or to visualize the motion produced by a given force, this skill will remain with you for the rest of your life, and it will have like numerous applications in all fields of engineering. Imagine that in your job, for example, in practical field, you are a mechanical engineer or an aeronautical engineer, and you know exactly a machine part which needs to move from one point to other to serve a particular purpose, and you are asked to design an assembly or a system to produce that motion, right. So obviously you should be able to quickly imagine what forces would be required to produce that desired motion, and then you will all be focusing on how to develop an assembly to apply those forces to that machine part. Similarly, if you are a civil engineer, you might be interested in motion of a particular building component under ground shaking or under earthquake forces, right. So you might want a particular component to move in a particular way, and you might be imagining that what forces would be required to produce that desirable motion and avoid the undesirable motion, right. So it has endless possibilities if you can develop that skill quickly to visualize motion and force and their respective relationship. So what do you think if, for example, I ask you that in the same time scale at the bottom, from 0 to some time t, what do you think about these three cases? What forces or what force will be required to produce this kind of a motion? For first 3 seconds you have a positive acceleration. Newton's first law says that you must have a force to describe acceleration, right. Second law says that that acceleration should be proportional to the force applied, right. So the first 3 seconds you must imagine a force which would be applying to your particle to produce this acceleration of 10 meter per second square, right? So I can say that for first part of 3 seconds, like the same duration, you must have, for example, a positive force to produce a positive acceleration, right? Let's call it F1, and it should stay with the particle, it should keep on applied to the particle for whole first 3 seconds. It shouldn't be just applied and then finish, right? Because the acceleration remains constant, the force to produce that acceleration should also remain same for first 3 seconds, right? Then from 3 to 7 seconds you don't have any acceleration, you have a constant velocity. So the particle, if it is moving on a frictionless surface, or if it is moving in space without any air resistance or any drag, it should still keep on moving with the constant velocity without any additional force being applied, right? So when the acceleration suddenly became 0 at 3rd second, the force should also become 0, right? So the F1 force, I can just double this line, that it remained there for first 3 seconds and then suddenly became 0, right? So at this point you have 0 newtons, for example, but for first 3 seconds you have some F1 newtons, and that 0 newton actually will stay up till 7th second, up to this point, and now you have a negative acceleration, right? So negative acceleration. So if, for example, the particle is moving with a constant velocity up to 7th second, you need a new force at the 7th second to describe this change in acceleration again, right, from 0 to -5. So first law says that whenever you have a change in state of a particle, you need a force to describe that change, right? So it means that even that information is not given to you, but you can think of some force, let's call it F2, which was applied at 7th second of this motion, which is responsible for producing -5 meter per second square acceleration. Now that force had a magnitude which couldn't suddenly bring the motion to rest, or it couldn't suddenly stop the motion. The particle will still take few seconds with positive velocity, right, this much time. It will take some time to exactly make the velocity equal to 0 and then change the direction of motion, right. So for a few seconds the particle will still remain, although the F2 started from this point onwards, but particle still continued in the direction of F1. So it is still under the influence of F1 up till this point when velocity became from positive to negative, right. From this point onwards the velocity became negative, which means the particle changed its direction and now it is again started coming towards origin, right. So you need actually two forces to describe this kind of a motion or produce this kind of a motion, right. First force should apply for first part and then it should become 0, and then you must have a second force. So the magnitude of F1 and F2 will actually decide how quickly the velocity increase to a certain constant value, or how quickly it decrease up to 0 and then become negative, right. So the slopes of these lines are actually dependent on the forces F1 and F2, which are actually producing these accelerations +10 and -5 meter per second square respectively. So it is very important for you to develop this skill now to imagine forces which will produce a certain given displacement, velocity or acceleration.